Seriously. Okay. Oh, we were supposed to rewrite process expression in terms of our tokenizer. All right. Okay, so let's do that first, and I got some other cool stuff for us to do. All right, so we said that our expressions have no spaces, right? They look just like that. All right, so what I'm going to do is I'm just going to take this line of code, cut it from there. Let's bring it down here into process expression. Let's just get rid of all this crap. Be easier that way. All right. So process expression takes a string in as a parameter. Right here, we're going to parse it on plus, minus, times, divide. And we're going to pass true in as the third parameter. Say, give us the operators as well. Give us the delimiters as well. All right. So now we're going to say while st dot has more tokens, has more elements would work too. But I showed you that has more tokens. So, hold on.
Your return.
Oh, thank you. We'll just put that in later. So while st dot has more tokens, we need to start looking at those tokens. So why don't we say st or string cur token. Give us a variable for that, and we'll say cur token is equal to st dot next token. So we'll read in that token. Now we want to find out if the token we just read in is a operator. Okay? Well, our is operator guy takes in a character as a parameter. So if the token we just read in is a operator, it's going to have exactly one. It's going to be the length of one, correct? But the thing we need to be careful of is what if we also read in a number that has a length of 1, like a 7. But since we know an operator, since we know the smallest token would have a length of 1, we can get char at 0. So what we can do is we can say if, what's this guy called, driver? If driver dot is operator of cur token dot char at 0. If that's a true statement, then we're dealing with an operator, right? And if we're dealing with an operator, we have two options. If curop is currently the question mark, this is the first operator we're going to run into. Keep going, right? So if curop is equal to question mark, then set curop equal to cur token dot char at 0. Otherwise, if this was not the first operator we ran into, then we need to do some math. Correct? So for example, our string might look like this. So when I run into my first operator, I don't do any math because I just need, like, that's just getting the ball rolling. But when I hit my second operator, I need to make sure I do the math for the first two numbers. That makes sense? So I need to do some math down here, and I'm going to be putting my answer inside of a string called answer, right? So we're going to say answer, or an integer called answer. So we're going to say answer is equal to whatever answer currently is, plus driver dot do math. And do math is going to take in curop. It's going to take in our first number, which should be inside of curnum. And does this guy take in an int? So that's inside curnum, the string. So we're going to say integer dot parseInt curnum actually we didn't even need cur token, did we? I'm going to get rid of cur token here. We're just going to use curnum to store it. Actually, I'm lying. We do need cur token. You'll see why here in a second. So integer.parseInt curnum, that'll give us the last number, and then integer.parseInt cur token for our next number. And we'll do that math. So we'll call our function do math, which we'd already written, and add it to whatever our answer is. That make sense? That's if we're looking at an operator. That's the stuff we do when we're looking at an operator. If that just happened, actually, we're okay with that. If we're not looking at an operator, we must be looking at a number, correct? And if we're looking at a number, what do we do with it? We set curnum equal to cur token. To keep our running numbers. So if we're looking at it as an example, we start reading in, our very first token we'll get is that guy. We're not getting him one character at a time, we get him as an entire token. Is that guy an operator? No, he's a number. So we'll store him inside of curnum. Then, that's our next token. Is that an operator? Yes. Is our current op currently a question mark? Yes. So it's our first operator, so we'll overwrite our first operator with a divide sign. Then, next token. Is that a number? Yes. What do we do with the number? Retro. We just overwrote the previous number. So when I run into a number, if there's already a number inside of this, what do I need to do? Because what I'm about to do, what my code currently says to do is say, take this number 2 and overwrite the 123 with it before I had the opportunity to do the math. Correct? Well, what do I need to do? Probably need more than one variable. So we're going to replace curnum with num1 and num2. Give myself 2 numbers. And we'll set num1 to the, we'll set both of them to the empty string. Okay. So if I'm in this else, I know I'm dealing with a, and actually this will be num1, and this will be, well, we can say cur token, that's fine. We'll revisit that here in a second. So inside of our else, if we're looking at a number, we need to ask ourselves a question. If num1.length is equal to 0, if we're currently looking at something that doesn't, if we don't have a number in num1, then we'll set num1 equal to cur token. Else, if we do have a number in num1, we'll set num2 equal to cur token. That make sense? So that's what we do when we see a number. We set one of our 2 strings equal to our number. Go ahead.
Don't you need to set the num1 and num2 back to empty strings at some point?
Absolutely. Yep, so that's, we're going to come back up here and revisit this. All right, so this is what we do down here. If we run into a number, we put our empty, we put that number into the first empty string we have, either num1 or num2. Now up here when we do math, cur token, that guy might be num2. So what will we do? We will say, when we're doing math, we're going to say, take our answer, num1, let me think through this here for a second. debating how I want to do this. Do I want to have two strings, or do I want to do it with one string? Okay, read in this, store it. Read in this, store it. Read in this. We can actually do this in a better way. Yeah, let's just do this in the better way. So we'll go back to kernum, and let me just dump all this. Let's just start from scratch here. Most of it's going to be the same. All right. So as we walk through here, we're going to run into a number. That is something that is not an operator. So let's go through that way. So if driver dot is operator cur token dot char at 0, if that is not true, which means we're looking at a number. If we are looking at a number, what are we going to do with it? We're going to put it into kernum. All right. Kernum is equal to cur token. Else, if we're not looking at a number, we must be looking at an operator. If we're looking at an operator and the current operator is a question mark, that means that's the first operator we ran into, right? If it's the first operator we ran into, what are we going to do? We're going to set, so we're going to say if cur token dot char at 0 is equal to the question mark. If that's the first guy we run into, we're going to set cur op equal to cur token dot char at 0. So pretty much the same logic we had before. We're just doing it a little bit backwards here. All right. So that's if that's the first operator we ran into. If it's not the first operator we ran into, then we're probably going to have to do some math. But let's go through the motion of reading in our second number. Okay, so at this point, we only know that we ran into our first operator. We run into our first operator, set cur op equal to that operator. Now, we just read in another number. If we read in another number, and we already have a number, how do we know we already have a number? So inside of this guy, when we run into a number, before I just set kernum equal to that number, I need to check to see if this is my first number or if it's my second number. That makes sense? So if kernum dot length is equal to 0, if this is the first number I've bumped into, set kernum equal to that number. Now, if it's not the first number I've bumped into, that is to say, if I have already read in the 123 into kernum, and I've already read in the divide sign into cur op, and now I've read in another number, now I need to do math with those numbers, right? So what am I going to do? Where am I at? So otherwise, I need to do math. What math am I going to do? I'm going to take kernum. I'm going to apply cur op to cur token. Now, do math returns an int. Okay, this will actually be an interesting way of doing this. I'm going to get rid of my answer. I'm not going to have an integer. I'm actually going to keep my running total inside of kernum as a string. Okay, so when I do math, I'm going to say kernum is equal to. the empty string concatenated with driver.doMath curop. Num1 is integer.parseInt kernum. Num2 is integer.parseInt curToken. Okay, so I'll do the math with the current op, the current num, and the current token, getting a number, the result of that math. And what I'll do is I'll overwrite kernum with the string version of that result by just concatenating that result onto the empty string. So this is a powerful little problem solving tool. If I take the integer, if I say the empty string concatenated with a 5, this gives me the string 5. It's a quick and easy way of turning a primitive type like an int into a string. So now I have the string version of whatever's returned by doing math. And I'll overwrite kernum with it. So kernum has my running total, if you will. All right? So what did I just do? I read in this number into kernum, read into this number into curop, read this number into curToken, recognized that I already had something inside kernum, so I did this math, storing the result inside of kernum. So now kernum has a value. Make sense? Now, in order to not do math when I run into an operator, I need to set my operator back to question mark. See, in our previous version of this, we did math when we ran into our second operator. Now we're doing math when we run into our second number, because we're getting our numbers as full-fledged tokens. So, after I do some math here, I'll go ahead and set curop back to a question mark. Why is that? Because when I run into an operator, I look for a question mark. Now the question is do I ever doing math this way? Every single time I hit an operator, all I'll be doing is setting curop equal to that operator, won't I? I'm never doing math as a result of hitting an operator. So I don't even need to worry about this question mark stuff. I don't need to start curop off at a question mark. I don't need to reset it to a question mark. And I don't need to ask if it is a question mark. If I see an operator, store it. That's it. Every time I see an operator, store it. So kernum, if that guy's length is 0, what does this mean? This is the first number I ran into. Otherwise, what's up? Is ran into. This is the first number there we go. I ran into. Otherwise, I need to do some math because it's not the first number I ran into. From that point forward, there will always be a number inside of kernum because kernum is my running total. Okay, so what are we doing here? Read this in, that's my first number, set kernum equal to that. Read this in, set curop equal to that. Read this in, kernum already has something in it, so do the math, storing the result of that math inside of kernum. Read in an operator, set curop equal to that. Read in this, kernum already has a value in it, so do the math with this operator, curToken, and kernum, which is the result of that previous math, so on and so forth. That make sense? So now what we can do, it wants me to set curop equal to something to begin with because this guy is going to yell saying it might not be initialized. Let me actually show you that. So here's this error we have down here. It says the local variable curop may not have been initialized. So when we're inside of this if-else statement, Java is not necessarily positive that you have ever given a value to curop. that make sense? We know, because we're writing this code, that we will have hit a cur op before we do math. So we need to appease Java by going ahead and setting cur op equal to some starting point. It doesn't matter what we put in here. We can put a period, we can put a question mark, because we're never going to use it. We're just giving it an initial value to make it happen. Okay? When all is said and done, we're going to return integer dot parseInt cur num. That makes sense? So we're walking through it pretty much the same way we did it before, except now we're performing math upon seeing a second number rather than seeing an operator. Rather than seeing the second operator. And we could have made it work the other way as well. The important thing is doing it this way, we don't have to worry about having one extra number trapped at the end like we did before. Remember before we had an extra if statement at the very end saying that if cur op is not equal to the question mark, assuming we had at least one operator, then we need to go ahead and grab our final number out of cur number, which we were building up. Remember that? Now we don't deal with end of string because we're using the tokenizer. Okay, so let's test this on something that I can do in my head. We're going to have 12 times 2. So we'll start off with that. And we will print out the result of that guy, which should give us a 24. So there's our 24. Minus 1. Oh, here. Let's do minus 10. Well, let's do minus 1 first. So that should give us 23. Then let's do minus 10, which should give us a 14. Divided by 2. Actually, let's do divided by 3. Gives us a 4. It's actually 4 point something, but it's integer math, so we do clean division. Plus, minus. Oh, we don't have a plus. Plus 30. 300. Plus 300. And 1. 3001. KK, thanks. So this should be 3005. Final answer. That makes sense? So we used our string tokenizer to repurpose this guy. All right, questions on that? So that was your homework assignment. How many of you got that working? Whether you did it the same way I did it or not. My guess is most of you probably just changed up the code that was already there to use tokens. Is that a true statement? Okay.
Same variables and gutted everything else.
Okay. So where once I got about a third the way through it, I saw an opportunity to show you how to avoid that extra if statement at the very end. Make it maybe a little more efficient, something like that. All right. So questions about this? So we had like 5 people who got it right. How many people worked on it for at least 2 hours? Wait, hold on. Who got it right again? Okay. So worked on it for at least 1 hour. Who didn't even try to do it? Who gave it 15 minutes? So you completed it in 15 minutes.
Roughly.
Yeah. Nothing wrong with that. Faster than I can do it. Jeez.
I forgot about charat.
Forgot that charat existed?
Yeah, so I spent 2 hours trying to figure out how to change a string into a char for 2 hours. It wasn't fun.
How did you ultimately do it?
Using charat.
You said you forgot about charat.
You remembered. Yeah, I forgot about it, then I remembered after 2 hours.
Oh,
Yeah.
I gotcha. So you were thinking along the lines of how do I turn a string into an int? You know,
yeah.
integer.parseInt does that. Well, okay, how do I do the magic of turning a string into a char?
Yeah, and then I finally remembered.
I gotcha. Well, that's good.
I was really sad.
You won't forget that again.
No, probably not.
No, actually, that's a very good example, though, of what programming is all about. It's not about doing this stuff and getting it right. I fully expect most of you not to get this homework done and correct. But I fully expect most of you to spend an hour or two on this homework, struggling, learning all the things that don't work, finally getting pissed off and walking away. Okay? But if you only spend 10 minutes on it, or you don't spend any time on it at all, you're not getting that experience of bumping into 10 or 20 things that don't work. So as you're going through doing this homework assignment, those of you that finished it, the hope is, well, either if you just knew how to do it and got it right, that's great. That means you're way ahead of the curve. But for the rest of you, what I want the experience to be is that you do something, oh, I think I got this, and all of a sudden, like, oh, crap, why doesn't that work? Then you explore that, and then you're like, okay, well, now I understand why that doesn't work. That's not the right answer.
Print statements are your friend.
Yeah. So then finally, in the end, even though you don't have the right answer, you've learned 5 things that don't work. Now, those things have been assimilated into your problem-solving, I guess, toolbox. So then later on, next time you try to solve a problem similar to this or solve another problem that involves similar stuff, maybe you won't go down those 4 paths that you know won't work. Now you'll go down a 5th path that still might not work. That makes sense? And eventually, you will have pretty much done everything the wrong way. And the only thing left is to do it the right way. Does that make sense? That's the experience we're looking for. Same thing goes with tennis, right? You've hit a zillion bad shots. And now, let's say you have a good forehand? Okay, so now you've learned what works for your body mechanics to hit a solid forehand. Yet you've hit 1,000 bad forehands. Probably 1,000,000 bad forehands, right? So it's the exact same thing. He knows all the stuff that doesn't work. Probably hitting off your heels most of the time, aren't you? But tell you what, these tennis players today, just lazy footwork. Everybody's hitting off their heels like Nadal. But he proves it can work, doesn't it? I mean, he hits all these winners off his heels. Just throws the whole mechanics of tennis out the window. Real problem is athletes are better today than they were 10, 20, 30, 40 years ago.
There was a gift just that I saw just a little while back of the difference between gymnastics vaults with current gold medal versus what was it, 50 years ago?
30, 40 something.
30, 40?
A long time ago.
Yeah.
Right.
Yeah. So 30, 40 years ago, it's just basically bounce off the springboard, do a cartwheel off the vault, and then land. And that was it.
Yep.
And then
And the person looked like a stick figure.
Yeah, pretty much.
Yeah.
And then gold medal now is vault off, do X amount of flips and twists, and then land.
Yep. And the person looks like an bend an iron bar. Right? I mean, the athletes today are ridiculously more muscled, and part of it's probably nutrition, part of it's probably like steroids and crap. we have better drugs for performance enhancing stuff. But I think a lot of it has to do with just training techniques. We have better equipment today. Just think if Rocky Balboa fought in today's world. He wouldn't be punching sides of beef. Have you seen that new movie that's coming out with him in it? It's like a new boxing. Hold on, everybody in here has seen Rocky, right? Like the original, not this remake. Okay, so what was the best Rocky movie? Rocky IV, the Russian. Exactly, that's the correct answer. What was the worst Rocky movie? Absolutely 5. Actually, the latest one, Rocky Balboa, wasn't bad. It was actually done relatively well. Everything was going to look great compared to Rocky V. But like, if you're a Rocky fan and you haven't seen Rocky Balboa, the one that was made like 2 years ago, something like that, it's not a bad watch. You won't leave ticked off. You'll leave like, it wasn't bad. But now there's a new one. It has Rocky Balboa. It has Robert De Niro. Well, not Rocky Balboa. It has Sylvester Stallone in it and Robert De Niro, and they're like former, heavyweight boxing champion guys from 30 years ago, let's say, and they had like this great rivalry in the ring. They just hated each other. And now it's, like 50 years later or whatever, 30 years later, they're old. They're old and fat and out of shape and all this stuff. And there's a video game place that wants to make a game of these guys. So they have to come in with the green suits on to do their moves. And they end up misscheduling it so these guys bump into each other again. Okay, so, and they hate each other. So a fist fight breaks out when they're in their little green suits and they're 65 years old. and it goes viral on YouTube. And now there's a rematch between these guys. But they're, so they both get trainers. But these guys are just old as anything. And so,
Crunch.
Yeah, so I mean, it's kind of funny.
What is that?
I'm trying to think what the name of the movie is, but it's Sylvester Stallone's in it. It's coming out like probably in 3 months or something like that. So just search for Sylvester Stallone on Internet Movie Database, and you'll see the movies he's currently working on, and it'll be one of those. It's him and Robert De Niro. I mean, it doesn't look like it's going to be a great film, but if you're a boxing fan and you kind of like the Rocky type feel, I think it'll be similar to that. Grudge Match. Yep, it looks pretty good. It'll kind of be, I think, somewhat interesting, like the Rocky Balboa movie, which was, had the current champion guy that's undefeated, but they were concerned that his competition wasn't that strong, so he really wasn't being pushed. And then they do a charity fight against, retired old Rocky Balboa who's got joint problems and stuff like that. And they train him and says, okay, well, you're not quick anymore. You don't have this. So all we have is blunt force trauma. So he goes into training, and then, the current champion is a little bit surprised that this old man is hitting him so hard. But I think this movie will be similar to that. You'll have these guys, these old guys, and they get in better shape than you would expect them to. And the fight probably ends up being a pretty entertaining fight in the end. My prediction is it'll be a draw. That's my prediction. And then they'll probably end up becoming friends or something like that. Which would be the stupid part.
Yeah.
It would be so much better if we went in expecting that. And just one of them just kills the other one. Just like literally it's like the whole fight is like 15 seconds long and the other guy dies. Literally dies. And like the ref doesn't stop it. Like, you have the Sylvester Stallone guy, like just punching him when he's on the ground over and over again. They should have me make this movie.
At least write it.
What would that look like if I wrote the screenplay of a movie and they let me do whatever I wanted to?
Oh.
What would that be rated? Could they show that in the United States? Or would you have to go like behind the Iron Curtain or something?
Yeah. It could be like a torture film.
It's like, well, that was tastefully done. I mean, that's actually the whole reason that I got for the Xbox One that I got the one that comes with Rise, Son of Rome. Have you seen the previews of this thing?
Yes.
I mean, like, you get to choose how to decapitate people. Like, have you seen the movie 300? How that stop act, that's like the play style of Rise, Son of Rome. Like, you have a little short sword, you come up behind somebody, you stab your sword through the back of his neck, it comes out the front, and then just because it's the most convenient, you just pull sideways because that's how you get your sword free. Right? Just makes sense. You can like stomp on people's faces and like invert their nose. I'm probably going to suck at the game because there's probably like a good strategy to like do stuff, but I'll just always want to decapitate people. I don't care what they come back as. I'll just decapitate them again.
It's like me when I play Call of Duty. I just throw tomahawks. I die a lot because I just run out.
Those games are too fast for me. I can't even make it that long. My plan is after I finish beating this game for PS4, I'm going to beat Knack, the game that came with it, which is actually quite fun. I think I'm gonna get Battlefield 4 and force myself to get good at it.
For Xbox?
Huh?
For Xbox?
I don't know if I'm gonna get it for Xbox or PS4. You want me to get it for Xbox so I can kill you in it?
No, sure.
What, you don't think I'm gonna be good enough? Because I should tell you, I've never lasted more than 10 seconds in any first-person shooter game. So I'm just, You know, I just want to know what. I just want you to be aware of what you're up against here.
In Rise, there's a execution where you stun the person with your shield and you come up underneath and chop off their arm and their bone, like you can see their bone, and then you come from the side and chop off their leg.
And then you rip their arm off and actually stab them in the face, like under their chin, with their arm bone.
You would be able to do that.
Body python skin.
That's what they should have done. See, if they had me involved,
That's how Rocky.
they wouldn't stop it and cut arm off, expose bone, then cut leg off. They would have had the third follow through of decapitate with arm bone.
Expecting my kids to be able to play this in the future.
Huh?
Expecting my kids to be able to play this in the future.
Yeah, but I mean they'll play the more gory version. You wouldn't let your kids play that?
Sure. It's not like if they start going nuts and they get thrown in jail, then stop them.
That's their problem.
I mean, the only way somebody can actually track it back to that, like, you know, video game violence, is that they actually decapitate somebody with an arm bone. Otherwise, it could be literally any game.
Oh, you what? Oh, well, that's not that.
That's like if somebody goes around on a killing spree with a samurai sword. That's like Assassin's Creed, right? Isn't that what the guy uses? Katanas? What is he using? What's the game that has the guy with katanas?
Not very specific.
Well, pick a game that people like as a dude who uses katana swords. Besides Teenage Mutant Ninja Turtles.
There's a freaking Walking Dead that uses one.
What does Assassin's Creed guy use?
He has the blades that come out of his wrist. Those like
Oh, I got to get some of those.
Yeah.
Wrist blades? You don't get a more entertaining class than this. Does not exist on campus. Okay, so questions about that, or about how to decapitate a Roman soldier with an arm bone. Okay, so let's do something cool here. I'm going to create a new class.
Have you been recording?
Yeah, it's a Mavericks thing. It's there.
Oh, okay.
Like it's like some screens. They were asking this last night. Some screens it doesn't show up on here. Other screens you can see it counting and everything. And some screens it literally just shows as a bunch of zeros. Like it took an initial picture of it, like a screen capture of it when I first started it, and that's just the toolbar. Yeah. What? Oh, that's fine. He's going to kill deer. Use some of the things I taught you today.
I will.
Use their leg bones.
Okay, so we're going to create a new object. Now the question is, are you asking if I was recording because you want to go back and review the programming stuff, or because you want to show your friends what your professor was talking about decapitating people with an arm bone?
Both.
But I don't believe you. All right.
It pretty much is just to go back to this conversation.
Well, good. Just so you know, I have added advertisements to my YouTube channel. That way, I can monetize my lectures. All right. So we're going to create a new class.
Views for that first?
Huh? What'd you say?
Don't you need a lot of views for that?
It allowed me to do it.
Really?
You get
I thought
money
you were
for that?
kidding.
Hmm?
You get money for that?
I assume that's what monetize means. I guess we'll find out. It's my experiment. All right, so I'm going to create a class called security. Actually, I'm not going to call it security. I'm going to call it Caesar. Huh, you think that's random. It's actually very related to what we're talking about here. It just happens to connect up in a funny way. Sure. Yeah, whatever. All right, we're going to call it Caesar. Now, the goal of this is we want to be able to create some text. Let's go to our driver class here and
Delete everything.
try to delete all this crap. This is garbage. I deleted it. Do you not want me to delete it? No, I can undelete it. We're good. Scream now. Okay, so I want to have a string that looks kind of like this. But now, as you can see here, it's a secret message. All right, how many of you have ever heard of a Caesar cipher? Do you know what a Caesar cipher is?
No.
Did you take the security class?
Yeah. No, I said it in Heidi's senior son.
Okay, so Julius Caesar used to write secret messages, well, write messages that he wanted to secure for transport. So he would use something that he created called the Caesar cipher. I assume he probably didn't call it the Caesar cipher. Somebody else probably later named it the Caesar cipher. But he used a cipher. A cipher is an encryption algorithm. That is something that takes plain text and turns it into jumbled text, something that doesn't look intelligible. Make sense? Now, the way this works in a Caesar cipher, just for the sake of argument here, I'm going to make all this lowercase for right now, for this example. All right, so we have our alphabet. I'm just going to put this in a string called map. Now, sometimes the Caesar cipher is known as ROT 13, which stands for rotate 13. All right, so what happens is we go through a string, one character at a time, and we move that string 13 characters in the alphabet. So if it's a lowercase letter, we move it 13 characters in the lowercase alphabet. If it's an uppercase letter, we move it 13 characters in the uppercase alphabet. If it's not an upper or lowercase letter, that is, it's not a letter, we just leave it alone. Okay? So, a T, actually let me start off with this A. A is the better example. So let's start off with an A. An A would become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 would become an N. Okay? An A would become an N. An N, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 will become an A. Make sense? C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 would be a P. A T, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 would be a G. So notice that we wrap. Does that make sense? Okay. So for starters, we're going to write some methods out in here. Static char encrypt char. That'll take a char C as a parameter, and this guy should return a char that is encrypted using ROT 13. So if I were to pass it an A, it should give me an N. If I were to pass it a, what was the last one I did? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If I were to pass it a T, it should give me a G. That make sense? So I pass it a character, and it should give me the encrypted version of that character. All right, and for right now, let's assume they're all lowercase. Let's just get a basic version of this working. So to do this, we're going to need a string for the alphabet. Okay? Now, we're going to take in a char C, and that guy is going to be some character in the alphabet for right now. Let's just assume it's an alphabetic letter. So we're not dealing with question marks or commas or numbers, only lowercase letters for right now. We can assume that's what's coming in. All right, so first, I want the position of C in the alphabet. How do I get the position of C in the alphabet? Somebody else. Go ahead. Huh?
Would you go with the right bucket?
Well, I already have a string. I have a string that has all the guys in the alphabet right there. What power tool in your toolbox would allow us to quickly get the position of whatever char this is inside of this guy? Go ahead. Index of. So I'm going to say map dot index of C. So what will this do? This will return the position inside of map where C exists, where the char contained in the variable C exists, or -1 if it's not there. But I'm telling you right now it is there because we are definitely taking in lowercase letters in this little example. Okay? So after this line, pause will hold some number between 0 and 25 because there's 26 characters in the alphabet, 26 letters in the alphabet. Make sense? Okay. Now, so now I have pause. So let's say pause was for A would have been 0. How do I get that to get me to 13? Actually 12, right? 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, no, 13. How do I get from a 0 to a 13? If I have the number 0, what do I have to do to it to get me to a 13? I need to add 13 to it. Very, very good. Exhilarating. So we're going to say pause is equal to pause plus 13. Okay, now how do I get the n if I have 13? How do I extract the n out of map given the number 13? It's like pulling teeth in here, geez. If I have a string called map that has the whole alphabet in it, and I have the integer pause that holds 13, how do I get the character at position 13 in that string? Char at. You're just now getting here? What happened?
Wait.
Oh, did you? Oh, that's right. That's right. I guess I didn't even expect you to be here.
Show's only like a half hour.
Was the sound good? It went well?
I ran, of course it.
I don't believe you. All right, so how do I get the character at position 13 in map? Use the char at method. So I'm going to return map dot char at pause. That make sense? So this is a simplified version. We take in a char. We have a string that has all the letters in the alphabet in it. We have a pause that is the original position of the current letter in the alphabet. Then we add 13 to it, and then we return the new character. So for right now, if I were to call driver.encrypt, passing it an A, it should print out an N. That is A rotated 13. Somebody push the door shut, please. Thanks. So there's my N. But now, what if I passed it a T? T is at what position in the alphabet? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Is that position 19? 19 plus 13 is what? $32? Okay. What character is that bucket 32 in map? Big fat error message. We're off the end of the string. String index out of bounds exception. Make sense? Okay, well, what should have happened? Well, we should have started walking the string. 1, 2, 3, 4, 5, 6. But when we got to the end of the string, wrapped back to the beginning, 7, 8, 9, 10, 11, 12, 13. That make sense? How do we fix this? So that I can give it any letter in the alphabet and it will map to the right character.
Remainder 26.
Huh?
Remainder 26.
Remainder 26. So if I have 32 and I mod that by 26, how many times does 26 go into 32? Once, with remainder 6, right? So 1 times 26 is 26, 27, 28, 29, 30, 31, 32. Remainder 6. So I can go to bucket 6, 0, 1, 2, 3, 4, 5, 6, and get my G. That make sense? But now, what happens for that A? Did we just break the A? If I take 0 and I add 13 to it, I get 13. What's 13 mod 26? How many times does 26 go into 13? It's not a trick question. Go ahead. 0. 26 does not go into 13. So it's 0. 0 times 26 is 0 with 13 left over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That makes sense? So 13 mod 26 is remainder 13. 32 mod 26 is remainder 6. That makes sense how that's working? So what do I set pause equal to? I set pause equal to pause plus 13 mod 26. That makes sense? So I'm going to add those two numbers together. So if pause was 0, I'll have 13 mod 26. That'll give me 13. But if pause was, what was it, 16? Was that what T was? No, 19. T was at 19. If I have 19 and I add 13 to it, I get to 32. 32 mod 26 wraps us back around to the beginning of it. Does that make sense? All right. So now this should work for T. So T is a G. A is an N. B is an O. All right. So that's how I can encrypt a single character. But now I want to encrypt an entire string. So now we're going to put this inside of an object. We don't want to have all these wires showing. So we want to go into our Caesar object. And we're going to say that a Caesar object is going to be built using a string. So we're going to have private string source. Then we're going to create our constructor, public Caesar. This will take a string source as a parameter. And we'll say this dot source is equal to source. Then we want to have a method called encrypt. That takes no parameters and returns the source string encrypted. Now we've already written a method out here that encrypts an individual character. So I'll steal that method. We'll bring it in here. I'm going to take the static off of it, so now it's an instance method. I'm also going to make it private, so people can't access it outside of this class. Private means a method or member, so fields, constructors, or methods are only available inside the class they were defined. So private means I can only access this guy if I'm inside the Caesar class. Okay? So I have this method we just wrote and tested. I converted it to an instance method by taking static off, and I also made it private, so I can only access it inside of Caesar, which then means that if I'm out here in driver and I create a instance of Caesar, passing it S, I will not be able to say c.encrypt. I won't be able to call the one that takes a char. That makes sense? Because I made it private. Okay, so we have a method here internally that we can use that I can pass a single char to, and it will give me the encrypted version of that char. Now, our encrypt method, which returns the string version of our source string encrypted, needs to build a brand new string filled up with the encrypted version of all the characters inside source. That makes sense? So I'm going to create a string called encrypted. Start that guy off as the empty string. Then I'll create a loop for it I is equal to 0. I is less than this dot source dot length. I plus plus. And each time through there, I need to concatenate the encrypted version of the current char onto encrypted. And then after that loop's over, I'm going to return encrypted. Make sense? Everybody take out a piece of paper. Get your name on it. I want you to write the body of this for loop for me. Everything that you need to solve this problem is on this page right now. And in my comment, I've actually told you what to do. So I want you to show me that you can call our methods correctly and do concatenation and that stuff. All right, so I want you to write the code that would go between this opening curly brace and this closing curly brace. I'll give you 5 minutes.
What is source?
Source is our, yeah, I'm sorry, I guess I sort of lied.
So that's taking the
Yeah,
the string
source
from
is the string that was passed in when we created. So just for our purposes for this little quiz, source holds our unencrypted text.
All right.
So source is a string that holds, this is a secret message in unencrypted text. And we want to produce a jumbled string inside of the string encrypted. That make sense? One more minute. All right, pass it this way. Surely everyone got this one right, right? It was only one line.
I panic.
All right. So we're going to say encrypted is equal to encrypted concatenated with this dot encrypt character this dot source dot char at I. This make sense? All right. So to test that, I'm going to take these exclamation points off here because he doesn't know how to deal with them. I'm going to say system.out.println c dot encrypt. And there's our jumbled version with the exception that it didn't handle spaces. It treated spaces as a -1.
It printed a negative
No, it didn't. It added 13 to a -1, so all spaces gave us bucket 12, whatever the 12th letter of the alphabet is. Okay? So, for your homework, give you this as a starting point. using the code below as a starting point, update encrypt char such that it works for upper and lower case letters and ignores all non-letters. That is to say that non-letters stay the same as they are now. So a space is a space, a question mark is a question mark, an exclamation point is an exclamation point. That make sense? Then write the decrypt method, which should undo what the encrypt method does. Make sense? All right, and there's your code as a starting point. And this is due on Tuesday. Okay, we're meeting now, right? Okay.